So here I want to introduce how to use Simulink to solve ODE. So first I will give you a general introduction of Simulink, and then I will use example and to show you step by step, and for example, and what is the Simulink library and what's procedure to develop ODE in Simulink, and then how to do the simulation and plot the result. Before you watch this module, you should watch these 3 modules, and otherwise it will be challenging for you to understand this module. Simulink is a part of MATLAB, and the good thing for Simulink is it provides the block diagram windows, and then you could build a model by linking the modules from the Simulink library, just like the kid playing Lego, right? You put them together, you link them together, and then to represent the ODE model, and then you solve it. It's pretty straightforward. As I mentioned before, right? You could solve ODE in MATLAB in the command windows, and then you just type the function of the ODE. So another way to solve ODE is using Laplace transform. So you could watch these 2 modules, right, if you are interested to see other approaches to solve ODE. Anyway, compare these 2 approaches. It's easier for you to build ODE model in Simulink, and also it's easier for you to learn Simulink, because just like keep playing Lego, right? You put those modules together, you link them together, and then you get ODE. But it might take you more time to put this module together, right? And when compare with you write the command, you write the ODE function in MATLAB. So here's an example. This is a tank, so water flow in, then flow out like this, and then the liquid level in the tank, and because H described by this ODE. A is the cross section area, and D is the diameter, so D is given. And then Q in is the inlet flow rate, right? This is the unit, right? And KV1 is the valve coefficient, also is given. So at the beginning there's no water, so H equal to 0, and then we need to calculate the liquid level. But before that, please make sure that the unit of kV is defined in the meter and also in the second. So the time unit is second, and then the last unit is in meter. So therefore, you need to be very careful when you do simulation. You need to change right here, change the millimeter to meter. Also, this change the minute to second. Okay. So here's the model, and the question is now the Q in. So this Q in profile, and at the beginning is equal to 0.0035 cubic meter per minute, and then this flow in, this flow rate is kept for 6 minutes, and then change to 0.005 cubic meter per minute, and at 6 minutes, and then so your job is to, so this is the Q in. So your job is to get the profile of H, right? So what's the profile? So profile at the beginning is 0, right? So increases, right? And then at 6 minutes then increase again because the flow rate increases here. So what's the profile of H? Right. So this question. So what is the value of H at the 12 minutes? Okay. Right. So I want to show you what the model look like in Simulink, and you can see we're going to represent the ODE model in this diagram. So you can see you could take a look at this diagram. You can see that, hey, this is the input, right? So the input of the model, and then all this one is the math operation, right? Then this part is the output. You're going to plot the output. Okay, so you can see, hey, take a look at this diagram. You can see that we're going to we're going to get the modules from Simulink. The modules include the source modules like the step change, right? For example, the Q-in, those time constant, right? Constants, and also the time is the clock here. So we call this actually this the input modules, and then we also see as operation the math operation. For example, here's multiplication, right? And here's the minus, plus, something like that. And then we also in to solve the ODE, we also need to put the here integrator here, right? 1/s is integrator. So this is for integrator. And also we need to define function to calculate, for example, A, right? So this is the A times pi, right? And then we also need to define, right, this term square of H, right? Just like you see in the ODE model. Okay. So I'm going to show you how to define the function. So the last one is the sync. The sync just like the module right here. They save the data into variable, into T and H here. So this is the output module, and then you can plot the profile. Okay. Anyway, Simulink allow users to select their own simulation parameters and also server. I will show you later. Okay, now let's build the model together. So you go to MATLAB, right? You go to new, plus new, right here, new, and then you're going to get Simulink model here. So after that, and then you could build your own model. I just start my MATLAB. It may take a while. Okay. So after you build a new model, right, you save the model, right, and before, so you're going to say here, you're going to put new. So I will put blank model because I don't have anything here yet. It's pretty slow. And then after that, you give a name of the model, and then after that, you're going to go to the library and to get all the module you need. So here, see, so this is the one. So before I do anything, I save it, right? I'm going to save it. So I will save it. I will say is I will say model tank v0. Save it. Okay. So after that, you go to here. This is the library. So just click the library because you need the modules, right? From the library. Okay, now here is what you see. You see a lot of module here. Right? I'm going to show you here. So the module. So first I want to show you. So this is the library icon, right? You click it, you get the modules. So the first one is we also can blocks like this sources block. So you get step here, you will get go here, you can get sources. And then you get a step here, right? You also get sine wave. You can also get constant and time here. And then you're going to get the math operation. The math operation, you're going to use it a lot, right? So you go here, just math operation. So you get all this math operation, right? This divide, this game, right? Something like that. And then you're going to go to the to get the integrator. Remember, right? We only get the integrator, right? Something like this, right? dh dt dt, right? You get h, right? So we call this integrator. So you go to continuous, and then you get integrator here. So get continuous, this integrator. Okay. So again, you could define your own function. The function just like so. This is the function, and you could define a function, and then but you need to specify the input and then the output, right? And after that, you just give the input to the function, and then you could use the function to calculate the output. So I want to show you here. So the defined function is user defined function here. There's a category here. So user defined function. So you can get the function here. Okay. Now I want to show the sync blocks. The sync blocks is very important because you want to save the data. So here you go save to this workspace, or you also can use the scope to see the output. So you can see you're going to get syncs. So here workspace, where you could save the data in a variable in the workspace, or also you could use the display and scope to see the output. Okay. Now I want to show you step by step how to build a model together. Right. So firstly, you need to get an integrator, right, to solve the ODE. So we're gonna go to continuous integrator, right? So you just use the mouse to draw the integrator into the model. So this is the model, and here continuous, right, integrator. Just select it and then draw. And from the library and to the model. Okay. So you can see this is what you should get in your model. And so the integrator, the input actually is dh dt, right? And then this is the integrator, right? So this is the input. Do the integration over the input, right, over time. Then the output actually is h. Okay, so the input is dh dt is the derivative, and then output is h. So the integrator is 1 over s, right? So 1 over s. You will change the name. You will change the name, the label under the block. So for example, you just use your mouse and click right, the label here. We change to h. Anyway, it's just for annotation. It doesn't change the result, right? Okay. So after you set up the integrator, one thing you need to do is to set up the initial value for the integrator, right? Otherwise you will forget in later. So the default value of the initial value is 0, but in some case scenario it's not 0, right? But in this case it's 0. So just double click, and then you can see it's 0 here. But in some case scenario, the initial value is not necessarily equal to 0. Okay. So after you get integrator, you will change the label, right, under the integrator, and then you set up the initial value. Okay. Now we have the integrator, right? So remember the input of the integrator is dh dt. So therefore we need to put this whole term on the right hand side as the input of the integrator. So before that, we need to decouple the differential equation into different levels. For example, you could decompose this into two terms. This first one, the second one we call level 1. So right, and then in this places you could further decompose, right, into two terms. So for example, this is the first term, the second term, right, because of level 2. Okay, and then the last one you could see here, right, in this term you have a multiplication, right? This we call level 3, something like that. Anyway, there's a no unit solution for the decomposition of the differential equation. Different people may have different way to decompose the differential equation. But anyway, here's the way I represent the ODE, right? So this right is the integrator, and then this is dh dt, right? So you could type the equation in the label, right, and then you decompose as two terms here, right? This multiplication here. So this the 1 over a, another one is this second term here, right? And then for this one you could further decompose. This is 1, this is a, right? A is 1 over a, right? And then for this one you could decompose it as this q in, right? And then this whole term here, this second whole term is minus, the second term is kv times square root h. And then you further decompose. So this will be kv1, and then this will be square root h, something like that. Right, and then yeah, you keep going, and then finally you get a constant, right? Constants or input terms. Anyway, here I use different color to represent different levels, but you don't have to do that, right? Yeah, it will not change the result. Okay, so now I want to show you step by step how to do it. Okay, so the first, again, now we need to get a we want to represent the dh dt. So we have here there's a multiplication, right? 1 over a times the whole process. So we need to get multiplication is in the math to be. So typically I will get the module first before I link them together. So this multiplication, right, and then I'm going to type the equation here. Just make sure after I type it, and then I don't need to look at the handout, right? So I type the equation here. It's 1 over a times parentheses, right, q in minus kv1 times square root h, right? Square root, as I use sqrt h. So here I represent them. So I represent the equation, right, in the labels, right? So now I don't need to look at the head now. I already have the equation here, right? So so when you type the label, you need to be very careful, right? Try to type it right. Okay, now you can see it's 1 over a times the process. So you have 1 over a here. So 1 over a actually is a so 1 divide a, right? So we have a divide module here. So put this here, it's divide module, and then put. So to link it, it's pretty simple. You just select the beginning point and then link it to the ending point. Okay. So so I'm going to put 1/a. So similarly for the second one, we have we have q in minus. Alright, so there's a minus operation here. So you're going to get a minus. Here is minus recursive check. Okay, and then we will get this one, leave this one together, make it a little bit look nicer, right? And then get q in minus kb1 times square root h. Okay. This will be capital A, right? And then after that, I could get this input should be q in, right? And minus this would be kb1 times square root h. So I have another time product, right? Turn here, product. So I get here, or rather equation here is kb1 times square root h. Okay, so I'm done with this step. So now I want to show you we need to calculate square root h, right? And also a. So now I want to show you how to use a function to calculate a. For example, a actually is what? A is, right, is 1/4 pi d square, right? So we're going to represent a, use a function. So you get function, you get user defined function. This function, you draw this into the module here, right? This link it, this a, right? Remember, this is a. So the input of a is the d, right? So the input of a is d. So I would rewrite the equation a equal 1/4 pi d square, right? Now we define, so when we define the function, we need to define the input. So input here, d is u. We can rewrite the equation 1 equal to 1/4 times u1. Okay, so u, sometimes we have multiple inputs, and u1 is the first input, u2 is second input. Now we only have one input, so u1 actually is, so u1 equal to d, right? So this is square, right? So something like this. So I'm going to put it in. So I double click, and then I get 1/4 times pi. The pi is is a constant, and then time 1/4 times pi times u1, right? U1 actually we have only one input, so it's u1. Actually it's d, so we get square, right? And then we're going to put a d later. Okay, so similarly, to get a square root h, and then you get another function here. So you could get the mass operation, and then okay, I think I still use the function. Actually, you could use the square root module in the square root module in the mass category. Now I want to show you. I would say the input actually here is the input now for the h, square root h, right? The input is h, so you get square root u1, something like this, right? So u1 is the input here, so you get square root u1. Okay, so when you type the function, be very careful. When you type one places, you should type them the other half, right? You should type the places in pair to get u1. Okay, now I change this one to a. Actually I will change this one to square root h. Okay, so this is how we define a function. So the function is pretty powerful. So we had the math operation almost done, the model already done almost. Now you just need to put so to calculate A, you need to get D, right? But D actually is what? Is in the unit of millimeter. So we need to times the gain. The gain is 0.001 to change the millimeter to meter. So I'm gonna put the D and 150 milliliter actually is constant. So you're going to get the sources here constant selected, right? And then you put here. So you can move this around if you have space. So you can put D. So D, you double click to change the value of the constant. So it's 150. And then you put a D here. Right, again we want to change the unit from milliliter to liter, so you're going to have it times 0.001, so you get mass operation here. So mass operation you could gain here, show here. So get link this together, input to output, input to output. So you're going to switch this one to times 0.001, so you change the unit, right? So you could, if you can see the value, you could stretch this a little bit, and then you see the value here. So we say change milliliters to meter. Okay. So A is done. So you can see 1 over A. So we need another constant 1 here, right? So we go to the sources, get constant, you draw it down here. So this put here. So 1 over 8. This part's done. Okay, now let's go to the second part here as h, right? So where is the h come from? Remember, the h is the output. See? So this h, right? H come from where? H come from the output of the integrator. Remember, the output of the integrator h, right? So therefore you get the h from the integrator. So this h, just link this one to it, and then you could put the kV. So we get square root h done, but you still need a kv1, right? So kv1. So we can move this around. So move this. Okay, so get kv1 is constant. So we're going to go to the constant here, constant, and kv1. So we'll put here kv1. kv1 constant is equal to 0.00187. Okay. Again, you don't see it. You can stretch this a little bit. Okay. Now the last one is Q in, right? Q in. Again, Q in is a step function. Remember, again, what we have, and the unit is minutes, so we need to change the unit to seconds. So we divide Q in by 60. So we're going to here. So this Q in, right? You get step function. Then divide the Q in by 60 to change the second minute, right? So this change the Q in the second. So the step, so you could get step function up if you after you get step module, you just block, and then you double click, and then you can change the initial value, final value, also the step time. So remember, we change the unit to second, right? So therefore the 6 minute, remember we get a step change in the 6 minute, right? So 6 minutes actually is 6 times 60 seconds. Alright, that's why we say 6 times 60 here. Okay, now let's work together. So we're gonna get a step change sources here, step change here. Alright, I'm gonna change this to Q in, link this to the Q in here. Oh, actually I forgot to change the unit, right? I need to change the unit, and then I need to divide. So if you want to make copy of some module, you click the control key on the keyboard, and then you use the mouse, you could draw, you get a copy. Okay, or you just copy and paste. So this one I say is it change. So 1 minute equal to 60 seconds, right? So I put 60 here, double click, get 60. Okay, and then you're going to get a divide module, right? So you get math operation. So divide, and you get this input divided by 60, right? So we change the unit from minute to second. Right, this Q in, so you put it in here. Okay, so save it. So we have the module, the model, right? Input in Simulink. Now let's do, before that, remember we want to get a profile, right? T and H. So therefore we need to record the time. So we're going to get a clock here. The clock is in the sources. The clock, draw here. This time. This the time. Okay. So to plot the output, we need to record the output, right? So so we're gonna go to the sync category here. Then we're going to save the data into a variable in the workspace. So for example, I want to show you here. So we go to this, go to the sync, and then you go to the workspace. You draw it here. So this is for H. So so you could change, double click, you change the name of the variable name as H. Right, but be very careful. You need to save the output in the format of array, right? So I believe some of you going to have when you plot the output and then you get a lot of error, right? The most common error mistake I made is you don't save the output in the array format. That's why you can plot it. Okay, so this is H. So similarly, you need to save the so remember we're going to get a profile H over T versus T. So therefore we need to get another workspace here to record data for the time. So we double click here, get T again, change the format in the array, and then got it, right? Then you can see the H, you just limit it to the H here. So you can see here, you see a solid here, a solid dot here means these two lines are connected, right? If there's no connected, and then there's no solid dot here. Okay, now I'm going to skip the summary. So again, we need to save the data in the workspace, and then you need to save the data as an array. So this name of variable, and this the format of the variable. Okay, and then and then you're going to do simulation. To do the simulation, and then you need to specify the start time and then the ending time. So again, we're going to do the simulation for 12 minutes, right? 12 minutes equal to 12 times 60 seconds. Okay. So this is what you're going to get. Let me show you. So you're going to get the simulation. So simulation configuration, right? And then you're going to set so here step beginning time, ending time, right? If it's 12 seconds, 12 minutes, so 12 times 60. And then this server, remember server, and then you can see, remember I showed you before, right, in the module. So remember I showed you in the solving ODE in MATLAB, right, that module, and I show you what is the stiff model, right, ODE model, stiff ODE solver, right. Okay, but anyway, you could just select the program, select the server for you, or you could select the server by yourself. For example, for the stiff problem, you might select the ODE 15S, something like that. Alright. So anyway, the most important thing for you is the stop time, right? Okay, so okay, and then after that you could run the simulation. So you could run the simulation. Just click this icon. Again, this is the time for the simulation, right? And then you will see. So just see, for me is click this one, and then it's done. So ready means it's done. Okay, and then you could plot the profile. So sometimes you don't like the plot profile, you want to see the profile, and right, you could use the scope here. For example, you could use scope. You link this one here again, link the scope to the edge, and then you just run simulation, and then you double click the scope. Actually I forgot to set up the right, the queue in, right? So the queue in, the step time, actually is 6 minutes, right? 6 times 60, and the initial value is 0.0035. Remember, the final value is 0.005. Let me show you here, right? So 6 times 60, right? 0.035, 0.005. So this is the step of the inch of the queue in, right? Okay, now we save it again and then run the simulation. Hopefully this time it works. And then double click the scope, and then you see here, like this profile. Right, you could see, you could change here, right, to scale the profile to see the whole picture. So now actually I see the whole picture here. Okay, but tips, you don't use this one when you write paper, right? So we're going to, I'm now going to show you how to plot the profile and then save it as in the document, right? So you're going to use this command, and you could type this command in the command window, or you could set up, for example, you could set up a function as I showed you before, right? So now because it only have several lines, right, I just type it. So I could plot. I change the unit back to a minute, right? So I time divided by 60, and then I change the liquid level unit back to milliliter. So I times 1000, right? And then red, I see R means a red color, and then solid line, the line width is 2. So this right with again all the comments behind the percentage sign actually is for the annotation. So this is what I have, but I don't have the S label and Y label, so I put the S label here. S label. So you can get time. Right, so every time when you minutes, right? Every time when you plug your profile, you should make your figure look professional, right? So you should put the S label and Y label. Also the font size is 12. You could change font size, then Y label, and then here is to be liquid level H. Right. Here the font size also is font size. So now you can see, right? Okay, now I want to show you. Again, I showed you before, right? You could use the copy figure, right, and then paste this figure in the Word document, or you could use save as, right? So for example, I save this as, and then you could change this format. For example, JPEG, right? I would say liquid level. Okay, save it, right, and then you could see the figure, right? Also, you could change the resolution, use the export setup, then you could choose rendering, and then you could set the resolution you like. For example, and this is 300 TPI, and then you could go to export, right, and then you could get the again JPEG, right? You could choose, you get the figure with the required resolution. Anyway, okay, now this is the practice problem, right? So the question here is now the Q in is changed at time 0 this time. So change from time 0, and then for example you at the beginning is 0035, and then change to a Q in new value. Now similarly you get the H profile look like this, right? So the question is, I want to know what is the Q in for the liquid level equal to 400 milliliter. So what is the Q in value for the, so what is the Q in here? What is the Q in for to get the liquid level equal to 150, right? Okay, so we are done with this module.